My purpose tonight is to try to introduce to you KiCad if you haven't used it. Now, it may be that you've all used it. It may be that this is new to me and everybody else is going, I don't know what you're blathering on about. But my suspicion is that most people have used Eagle mostly, and one or two people have had access to expensive commercial toys. And I'm just going to assume that they live in a world of their own and won't be a bother to the rest of us. The rest of us don't have money to throw to sophisticated PCB and EDA software. And so we're looking for something cheap or preferably free. And KiCad is definitely free. I have no idea what KiCad stands for or where the name came from. I should really have looked it up so that I could appear to know what I was talking about, but I didn't. I'm sorry. So KiCad is a complete electronic design automation software suite, and it does pretty much everything apart from turn on your soldering iron and do the job for you. You can design and capture all of your schematic details. You can transfer those onto a printed circuit board and lay them out. You can manage libraries of symbols and components and footprints. You have a 3D viewer for your board so you can see what it looks like. There is an integrated Gerber viewer, and if you've used Eagle, you know that finding a Gerber viewer to see what your files look like can be a problem. And it's all around jolly good stuff. It's in terms of why you might pick it, I'm going to just compare it to Eagle because that's probably what most people have some familiarity with. Eagle used to be fairly rudimentary and was widely panned by all kinds of know-it-alls who could afford Altium as having a horrible user interface. And it still does. But my experience has been that while there were some improvements, a lot of it is still just strange and leaves me puzzled. KiCad also has a fairly arcane user experience, but then to be fair, so does every other piece of PCB software I've ever looked at. And if you pay good money for proper stuff, it just gets worse because inevitably to make more sophisticated software, people just add more and more to it until you become completely overwhelmed by the options. The most significant thing, perhaps, about KiCad is that it's completely free and it's completely unlimited. Now, if you've used Eagle, you know that it's a jolly good job that a Micromouse doesn't have to be any bigger than 80 millimeters by 100 millimeters, because otherwise you wouldn't be designing the boards using Eagle. You can make a bigger board, but you can't put any pads outside that area, and it's a constant source of annoyance. Not only that, the orientation is fixed. If I remember correctly, it's 100 wide and 80 high. You can't have a vertical, a portrait board. It has to be landscape. KiCad, however, you can have a board of any size. You can have up to 32 layers. You can have more complexity than you can throw a stick at. Since the last version of Eagle that was not Autodesk was version 7.7, I believe. And after 7.7, Autodesk took over and increasingly got you tied into their cloud-based ecosystem. And that all on its own was annoying. If you had been using Fusion 360, which was a lot of people's go-to choice for CAD software, and it still is very, very good. But inevitably, Autodesk, well, they have bills to pay and they pay a lot of people. So they've got to make some money somewhere, and they can't go giving away the crown jewels to any old Tom, Dick or Harry who comes along. So you can kind of understand that they would place constraints, but some of them are just annoying. And for me, their attempts, whilst the company made Eagle a much nicer piece of software in terms of capabilities, their attempts to integrate it into Autodesk were just horrible. I tried several times to make use of this integration. You're supposed to be able to design boards in the CAD software and transfer them to Eagle, and it just all went wrong again and again. And I just got really fed up with it. I pretty much stopped at 7.7. I got rid of my later versions, went back to 7.7, and that was that. At the time, I had looked at KiCad, and KiCad then was not nice to use. I didn't enjoy it. The user interface was weird, inconsistent, kind of amateurish. Since then, however, KiCad is a whole different beast. From version 5 onwards, it's a whole different beast. And now you're not, with KiCad, you're not beholden to Autodesk. And for me, that alone, even if it was clunky, that alone would be enough. Okay, the idea that your files are trapped up in the cloud and useless without signing on. What if you don't have a good internet connection? What if you're, on your travels somewhere and it goes, oh, no, now's the time that you have to sign in to verify your account? What good is that to you? So anyway, all these things, for me, the long and short of it is KiCad will do everything that Eagle will do and more, and it's got nothing to do with Autodesk. These two things alone are sufficient. There is a difference in philosophy with KiCad, which you need to know about and may become clear in a bit. In Eagle, when you plonk a component into a schematic, you get a kind of complete bundle. You get the symbol, you get all of the associated packages and footprints. It's all one thing, and then that gets automatically thrown into the printed circuit board when the time comes. This is both good and bad. On the one hand, that makes life very easy for you. On the other hand, you take a stock resistor in Eagle and put it in, and all of a sudden you automatically have, I don't know, dozens or even hundreds of different packages and footprints intimately tied up with it in such a way that you can't easily just go and say, as the problem David will have had on the UKMARS board, you can't just say, I want the pads on this resistor to be bigger, right? You just can't do it. It's all tied together. KiCad keeps the symbols separate from the footprints and the packages, right? So you just concentrate on getting the symbols in, and then later you associate the appropriate packages with them. At first, this seems weird, but actually, once you get the hang of it, it's got some huge benefits. There are some issues with KiCad, right? I'm not going to lie. There's a lot of change. It's an active project. It's well supported. It's well funded. Completely open source, but it is well funded and shows no sign of slowing down. Version 6 has been due out any day now for a little while, and you can expect changes there. And because of the changes from version 4 to version 5, if you go hunting around for guidance on the internet, do be careful that you are not finding old tutorials. Even on surprising places, like if you go to PCBWay and have a look at how to generate files for their software, you might find that it's referring to an old version. So that's just a caveat, right? The pace of change is such that don't go looking for tutorials that are more than about 18 months old, because they may very well not apply to what you're using. What are the problems? There's no auto routing. But then, to be fair, if you've done auto routing on Eagle, you've already been an unhappy person. Okay? It'll have a go, but it's not much fun, and the results they're dreadful, honestly. The only reason to do auto routing on Eagle is to prove to you that it is possible to make a route, right? Then rip it all up and start again. Has been my approach anyway. And the other reason that you're likely to not want to play with KiCad is you probably invested several hours in your existing software, possibly months, possibly years of subjective time in learning how to do stuff in Eagle, and you may be reluctant to go and dive into another bucket of nonsense to learn something new. But honestly, it's not that hard. It's an investment. And the library management is a little weird. I believe that's going to improve in version 6. Well, assuming that there's enough bandwidth to actually see what I'm doing, I thought the easiest thing really is to just run through a simple thing. And if you look at the thumbnail of my camera view, what we're going to do is have a look at this board here, okay, which is a replacement sensor board, maze sensor board for UKMARS bot. So when you, oh no, my mouse has gone. Oh no. When you first open up KiCad, you will see a welcome screen. You almost certainly won't be able to read the writing. Sorry. I tried to run the monitor at a lower resolution so that you could read it, and all kinds of things went wrong. So we'll live with this. What you see on here is the tools which make up KiCad. It's not a single integrated piece of software. There is a schematic editor. Excuse me. A symbol editor. That's me playing for time because I couldn't remember what it was. The PCB, footprints, a Gerber viewer, a bitmap to, I never use that. A PCB calculator, right? So you may have wondered how big must this trace be in order to carry 50,000 amps down to the front of my printed circuit board. This will tell you that kind of thing. And then there's just some utilities for the page layout. So I'm not going to start from scratch because it'll take too long. But if we have a look at the schematic editor, you get a fairly traditional looking view. This is an A4 page. You can change that if you like. And things, generally speaking, are pretty much as you would expect. Okay, you can go and add symbols. If I want to add something, I select the tool, click, it'll run through the libraries. There are comprehensive libraries, large libraries, and they're reasonably trustworthy. And if that's not enough, you can download a huge DigiKey library, right, ready-made for you for lots and lots and lots of parts. I think Adafruit have their libraries ported to KiCad, and I think SparkFun have as well. So it may be a long time before you have to go and design parts. But if you wanted to go and throw in a symbol, it's probably not a clever thing to pick something at the moment that has several gates in it. I don't know. So, just as you might expect, you have components and footprints. Just remember that what you're putting in here is just a symbol. You can move stuff around. Lots of things happen, and hit E. Whoops, missed. Hit E for edit, and up will pop a dialog with all sorts of interesting things about it. Much easier than going off to a separate library manager. This particular component already has a footprint associated with it, but that's only because I've short-circuited the whole thing, right, and done it all up front. Normally speaking, these symbols would not have footprints, but you could, if you wished, assign a footprint here for a specific part. Here is edit spice model. It's all of the usual things. The only unusual things that you might note here is that I've manually added the mounting holes in order to make them components. It's a funny thing, but it's more than simply sling holes onto the printed circuit board. And let's just zoom home, do text. the information on there. I had a question about that the other day, and it's interesting because in these bits, whereas in Eagle, it's a pain in the bits and pieces to find that. What I won't do it because it'll mess with stuff, but there are options for you to renumber all of the parts, top, down, bottom, left, right, or left, right, top, down, whatever, and it will assign part numbers for them all. There's a design rules checker. This is going to show me that there's an error in my design rules, and it says the global label ground is not connected to any other global label. And I can click on here and it will go to it. And there's a little arrow saying you have what this means in this particular case is there is a ground label to label this net, but I haven't got any other ground label for it to connect to. Okay, so we'll just make a copy of that, and we'll just go and attach it up there to one of the ground wires, and then run the design rules again. And enter 10, unlike Eagle, and it says you're good to go. This will detect all kinds, and this power the wires are giving it power. It's a strange thing. Eagle has a similar thing, but doesn't require you to actually mark a part as a power flag. So you've placed all of your parts lovingly, labeled them, given them values, labeled the nets so that the thing will know what is connected to each other. Your next job, generally speaking, would be to generate a net list. This is not something you have to do in Eagle. No, your next job, all of these tools run from left to right. So your next job isn't to generate a net list because it doesn't know what to connect to anything yet. Your next job is to assign footprints. And this will come up with a list of all of the available footprint libraries on the left, all of the individual footprints on the right, and your parts here. Now I've pre-populated this, but if we take this LED, for example, if I wanted to find, this is a 3mm LED, if I wanted to change that, there's an awful lot of footprints to look through. But it knows from the schematic that this is a 2-pin part. So if I go up here and say, I only want things which have got 2 pins, right? That's a start. I've still got an awful lot of things which seem weird, like battery holders and all that. But also LEDs, mounting, all kinds of things, right? So I'd cut that down to 2-pin parts, and I've got inductors, resistors, and yes, you saw them go by, or you didn't because of the lag, LEDs, through hole library, and highlighted is the LED that I'm using. Just an ordinary standard 3mm LED, and I can change that to something else if I want. It doesn't really tell you what it's going to look like, so I can view the footprint. Okay, nice, good start. And I can also get a 3D view of it to see if I have the part that I want. You can't change the color. You can have any color as long as it's red. But you could do this for all sorts. We could put a 5mm LED in there instead. View that footprint. See, that looks the same because it's auto scaled. And to be fair, pretty much the 3D view looks the same. So you have to keep your wits about you, but even so, it's not so bad. So we've got all of our part associations, and then having associated each symbol with an actual footprint and package, we generate a netlist, which is a text file which lists those associations. Okay, you have to do that. I won't do it now because it's already done, but it's just click the button and away you go. Once you've got your netlist, your options are, you can make a kind of spreadsheet and go and edit all of the fields of the parts. So if you were designing for manufacture, so if I were doing UKMARS bot from scratch in this, I would go through the symbol fields and I would add in things like supplier part numbers or those kinds of things. And once I've got all of that, I can generate, and again, I won't do it because it takes too long to explain everything, but I can then go and generate another spreadsheet or CSV file, which is a bill of materials for the project, right? So if you work, in general, you work from left to right through the options, add your parts, check your libraries, do your footprints, associate them, number them, and so on. You work your way towards a PCB. Excuse me. Right, and just anybody got any questions so far before we move on?
Peter, hi.
Yeah,
following your introduction to this, I followed that tutorial you sent me, which I can. If you're not sending that out, I can ping that out to everybody. That URL.
I have links at the end.
You've got links at the end. I went straight from schematic to PCB layout without going through creating a netlist or anything, and it just went straight through.
I followed the rules. It's entirely possible. I just haven't tried it, so I don't know. I can't claim that I'm hugely experienced with KiCad, but I already know more about using it than I do about Eagle, possibly. So
yeah, I mean, so I only did it because that's the way essentially the tutorial ran you through.
Right.
Draw your schematics, choose your footprints, get everything labeled up, choose your footprints, and then just go straight to board. You didn't need to do the intermediate step.
I'll give it a go later. It's quite possible you can skip the netlist generation, and it's possible that in version 6 it gets skipped. All these various steps are not things that you have to do in Eagle, and the reason for talking about them tonight is to point out that it is different, and it may seem like a bit of a fag to have to do these various things when Eagle you just click on board and away you go. But we all also have come across the big disadvantage to that in Eagle, which is that if anything goes wrong, it just says schematic and board are no longer in sync. You're dead. Now what do you want to do? Yeah, all right. I'll get on with it. So yeah, that inconsistency thing is it's a bit like having an intermediate table, to resolve many-to-manys in databases and things. Right. Okay. So
quick question about the where you put the label on for the ground. I noticed you already had a ground symbol connected to that point. So it's what about all the other places where you've got a ground symbol but no label? Does that mean they're not connected?
I knew somebody would cause trouble. I don't know. Honestly, you would imagine that because this is a ground symbol and has the value of ground, okay, library reference power ground, value ground, that it would also label the net. But the nets oops. Boom, boom, boom. Don't have a name as such, right? The net isn't defined by having a name. The net is, as far as I can understand it, anyway. And somebody will watch the recording of this and go, "Oh, you idiot." The net is defined by what it's connected to. So you'll see this on the circuit board in a minute. So there will be a net. Stop. There will be a net somewhere, almost certainly, which just says that it's connecting R12 to D5. And it doesn't care what it's called. But this one, because there is a label associated with that net, will have the name on the circuit board. And I don't think it will. Well, I can't even edit it now.
Right. But obviously the question is whether that ground and that other ground will be connected together.
They are. And I think the names on here do indeed imply the name of the net, right? Because they are connected together. So yes, I was not following what you were saying. They are connected together. The specific error is just about having unique labels.
Right.
It's not that this is not called ground. It's that this label is lonely and needs a friend.
So it's saying that ground symbol in Eagle, that would constitute a label called ground.
Yes,
but in this, it just doesn't.
No, it's an annotation, right? It's an annotation which also gives a name to a net where that's appropriate, I believe. I haven't looked into the details, but if I took away that label and this label, assuming that my mouse is catching up on the screen, if I took away those two labels, nothing would change.
Right, and you could put a ground symbol on the connector at the bottom, and it would then connect.
Yeah, it would be fine. Yeah.
We can try it later. So, yeah. Quick question. At the beginning, you said you gave the URL, which I think was www.KiCad.com or something similar.
KiCad.org.
.org.
And there are warnings about.
Yeah, because I was putting .com in, and it just keeps coming up with DigiKey. So I was trying to work out how to find it.
It's KiCad.org. And there are warnings on there that there is another similar domain that seems to be trying to catch people. So, but I'll put the links up again at the end. Right. So, if we move on to the PCB, here's my printed circuit, and for me, doing a schematic is tedious but reasonably straightforward, right? You know what you want to connect together. Your only real concern, or my only normal concern, is to try to make it look right. Yeah, inputs on the left, outputs on the right, flow of signals, all that kind of stuff, and then make it look reasonably pretty. And I know there are schools of thought about you shouldn't do this, you shouldn't. What they connect to. This is a stylistic thing which drives some people nuts, but for me, I prefer it. But a printed circuit board, well, printed circuit board is where art meets madness, or at least it is for me, because some of it is determined. So the board outline is predefined, almost certainly. The positions of some parts are predefined. After that, fitting everything in and connecting the damn things together with traces is I don't know. Some people love it. I think I like it, but it drives me nuts. So anything that makes all that a little bit easier is better. And what you see on your screen at the moment is pretty chaotic. But just like an eagle on the right here, you can turn layers on and off. And something which occurs throughout the program, I don't know if you can see, there's a little arrow by my mouse pointer up here. This is the active layer, and that layer goes on top. So at the moment, the active layer is the front copper, and you may just be able to see let's zoom in, that the front copper is on top. If I change the active layer to be the bottom copper goes on top, right? I find that very useful. And we've got an awful lot on the screen. So let's turn some of these layers off. The courtyards are these rectangles which represent how big the component is on the board. Okay, the courtyards should not overlap or the components will not fit. The fab layers are, in this case, the resistor value R3, sorry, the resistor identity R3 and the resistor value 10 ohms. You don't need that on the board. You may think you do, but you don't. Because once you've put the thing on there, it says 10 ohms on it, right? What you need at some point is to know what goes where, but you don't need a thing on there that says this should be a 10 ohm resistor. It's kind of redundant. Or you can print them out or whatever to say where stuff goes, but that information doesn't need to go on the board. So let's get rid of that. What you do need on the silk screen usually is the component identifier, right? This is D3. Upside down here on the back of the board is Q2 and so on. So we'll leave that on. In this, don't do that. On this view, you'll see what we're saying about that net on the board. This is a net. It doesn't care what it's called. It's just so that you can go back and have a look and make some sense of it. Whereas this one is labeled because on the schematic it has a label, right? So you can see what these things mean. What else do we need to see? So the front silks and the rear silks, whilst we're routing and moving stuff about, we can just turn those off. They're just text. They get in the way and clutter things up. Yellow here is the edge cut. That's the board outline. I'm turning it on and off. I'm not sure that's happening on your... It's not off. You have to kind of imagine that this yellow line...
I can see it turning on and off.
Can you? Oh, okay. On my other monitor, it just sits there laughing at me. So anyway, you can define your board outline. There are some constraints compared to Eagle. It's not so easy to do rounded edges and things like that. And you have to, and it's not, what's the right word? Can't think of the right word. The nodes at the ends of the lines are not connected. So if you pick up one of these lines and move it, it will not necessarily be connected. This is an annoyance, I confess, apparently to be fixed in 6. What else? Otherwise, I mean, if you want, I can show you how all this stuff just appears. It just appears in a big block on the screen, just like Eagle, and you have to shuffle it around into place. But that would just take too long to do physically. So instead, here's your basic board. I've defined a ground plane on the bottom of the board, and that's what this. If I want, I can turn on the ground fill the plane, or I turn it off. And notice that although I've defined it all the way on the outside edge, and indeed there is a design rule that says no copper should get within such and such a distance of the board edge anyway. So, but we'll turn that off because that confuses things. interesting thing I do like, a nice, neat, symmetrical layout, I have to confess, is routing and connecting them together. So let's just show you a little bit about how that goes. So here, between pin 1 of this resistor and pin 2 of this component here, which is the LED. No, it's not. It's the photodetector underneath, I think. We'll see in a minute. A trace on the others, and I thought, I would just be happier with a thicker trace. So let's do that. We're on the top copper layer. We'll select the trace tool, and we'll come and we'll start to. What I didn't do, of course, was change the size. Come up here and select 0.5 millimeter, and I'm just going to come up and you'll notice that it gets rid of the old trace for me. I'll come up there. This is on the other layer, and as I'm moving the trace around, see how it does not. There's a grey border around. No trace must be more than 8 millimeters from another trace or other copper. That's what that 8 millimeter. That's what that grey is around the edge. It won't let you. It just won't let you get on top of something that shouldn't be connected. So we're just going to replace that now. Let's do another. Let's do this one. Track. So what I'm doing. So track and make a route all the way through here. So let's see if we can fix that. I can just go back to the front corner. I want to bring it around this side. And when we do that, first off, it wasn't sure what I clicked. So if it's not sure, you always get a choice. And I've selected that. I'll go to my track tool and notice that it just pushes this other track out of the way. Automatically. It's pushed that one so far out of the way, it's even gone around the other side. Just missed. Come in there and replace. So that's that one redone. Oh, what did I do? Let's try that again. Right. So I wanted to go around that side and it didn't do it. I'll just do another one just to make sure that wasn't too. Actually, there's probably an easier way, which is to come up like that. Let's just go straight in. Oh no, dropped it. Never do live demos of software, it's just asking for trouble. That's better. So one of the nice things anyway, which I don't think came, did it come in 7.7 of Eagle? I don't know. Push and shove routing. It comes with the more recent versions. But this will try and find you a path. It will try very hard to find you a path, and it does quite a good job. I'll just do one more. I'll just shift that up there. And one thing to kind of know, if I do this one, it will move wires out of the way. So if you've got wires, they don't have to be a problem. So that's not good. And it's to find a way around the board. Yeah.
You're showing us stuff where you've already got a connection. When you're sort of starting to put those connections together, do you have sort of like air wires like you do in Eagle? You sort of say, okay, I need to get a connection from here to, or that need static at this point.
Yes. That's when you put the parts in, it's all connected by wires, and you just get to join them up. And when you start to route, it dims the rest, highlights the pads that you need to connect, and highlights the air wire, and so off you go. And we'll go up round there. So underneath, put in a wire. Because I've got a green one here, which I don't really want. Oops. I'll make this now. Okay, jump there. Also, these are quick kind of keyboard and things like that. This, we've got lots of these things, but I don't know about you. Whenever I come back to look at the board again, I ask myself what on earth I was on when I did it. So yeah, this is just horrible. But functional. To deal with the question of the pads, try a footprint if I wish, and change something about it. Okay, this one happens to be connected to Q6, and I can change all sorts of things about that footprint, and I can even go back to the library and edit it there. But actually, I have on this particular one, it's detached from, well, it's not detached from the library. The copy that goes into the net list is separate. So I can, let's see if I get this right now. That's a net, don't want the net, want the pad, edit the pad. Now I'm editing just that pad on just that component, right? And so it's currently 1.3 millimeters high. I like it 2 millimeters high, and there it is, sorted out. Obviously, for this particular case, because these are TO92 transistors and they have these ridiculously tiny pads, it would be better to go and edit the footprint. We won't go through tonight because it's already 20 past 9. But the point is that it's relatively easy to do these things. And so, for example, the job that David was doing on the UKMARS bot, the only way to change these things is to go back and edit the footprints in the library. Whereas if you wanted to, you could just go in this board, so you don't mess with your library. You could just go and change all of the pads on a part to a longer pad and be done with it. And that would be that. Right. Any more quick questions just about the PCB for the time being? No? Okay.
Yeah, I have one, Peter. Design rules.
Yes.
I just used the default design rules when I was doing my first board. Are there any that you particularly recommend?
No, the thing is to excuse me. The 3 places that I go and look, generally speaking, are Osh Park, PCBWay, and JLC PCB. And because I don't like dealing with PCB way, I don't really use them much. Okay. The only reason I don't like dealing with them is they're a little bit, they're kind of at you all the time to do stuff. So it's JLC PCB, and the JLC PCB site has all of the rules in, and you can put them in here, and there's a little button there for board setup. You can turn on and off all of the layers that you want. You can change the sizes of everything. The net classes, so you can assign a default track width to net classes and assign net classes to individual nets. There are general design rules about minimum track widths and minimum drills. All of this stuff, I've got a link later I can show you, is all readily available on the website of, and I think probably if you pick JLC PCB, because it's all on the one page, and just use them, it's easy. What I don't have is a kind of predefined set of design rules, such as you would load in. You can do that, export them, so it seems slightly redundant. If you can't export them, what are you going to import? And honestly, I've never hunted around to see if you could import them, but I'm sure somebody somewhere has a set of design rules. But like everything else, especially footprints, trust them at your peril. Right? Never use a footprint you haven't checked. Never use design rules that you haven't checked, because we all know that, well, just in the last couple of years, it's increasingly apparent that one of the greatest sins in the world is going and finding stuff on the internet and believing what you find.
Yeah, just a comment on that. Just a quick comment on that. I think you should always try and pick who you're going to get manufacturing the thing in the first place and set up your design rules before you start any of this, because so many times you go in and you use the default design rules and you find you can get little tracks through here, and you've got this fantastic PCB that's taken you months to sort out, and then you apply the ones from the PCB house and it doesn't fit, and there's just no way you can massage it right, and you can end up starting again. So you should. You're
absolutely right. Yep. You're completely right. It does take months to lay out a board, or at least it takes me months. Yes. Honestly, if you think you're going to be using a particular house, it would be prudent to check the design rules before you start. And of note in that sense is, I think PCBWay and probably JLC PCB allow clearances down to something like 3 or 4 mils, right, which is absurdly tiny. So it's better to go big. Go for 8 and 8 or 10 and 10. And if you really can't fit stuff in at 8 and 8 and 10 and 10, then consider finer. The larger the spacing and sizes, the more likely it is to function and be made properly. But yes, good point. Right, so you've got your printed circuit board, which is now a mixture of better and horrible. And I'll just save that. The next step is how to get it made. And some board houses will take Eagle board files direct. Some board houses will take KiCad board files direct. But the only safe option is to generate Gerber files. And to generate Gerber files in KiCad, there is a plot, because it all used to be done by plotting. And we have Gerber here, and essentially I find this much easier than Eagle. I always struggle and go and find the PCB manufacturer's set of CAM files for Eagle, because I chicken out. I don't really understand it, to be honest, but this couldn't be easier. So what do we need on our printed circuit board? We need the front and back copper. If we've got surface mount parts, we might want to include the paste layer, because if you have a stencil made, the paste layer is what defines the stencil. If you get a stencil made, turn them off, you don't need them. You need the silk screens so that you know what's what on the board. You need the front and back mask. That's interesting, I left that out. That's the solder mask to say, you know, which bits will be covered in your pretty green or purple or whatever it is, solder mask, and the edge cuts, the board outline. Otherwise, they'll think it's massive, and it isn't. We don't really need the footprint values, but we do need the footprint references. The edge layer should only be on the edge layer Gerber file. Some board houses want you to use Protel file name extensions. These are the GBL, GTL, and so on, but some don't. Turning it on does no harm. And you'll note, by the way, that I haven't filled in the ground plane. That doesn't matter. It'll do that for me because it's good like that. And then I just do plot. Refill them, you see. These have not been refilled. Do you want to refill them? Yes, I do. I've chosen to put them in a subdirectory called fab. You should pick a subdirectory because otherwise they'll just get mixed up with all your board files and you'll spend the rest of the night picking them out to one from the other. You also need to generate the drill files. That's pretty straightforward. They go in the same place. It's always Excel as far as I can see. There may be a rule about plated through and non-plated through holes being treated differently, but generally speaking, it doesn't seem to be a problem. Check with the board house what they want here for formats and things. So the Gerbers, by the way, are, where are we? The coordinate for Gerbers, millimeters. Coordinates for drill files, inches. That's a strange world. And PostScript, strangely enough, is what they use. Generate the drill file, done, done. Where are they? Well, they are all in this fab folder that I had before. And so you've got, they're sensibly named. They are the name of the project, the name of the layer, and then the Protel bit is GBL, GBS, GBP, and so on. What do you do with them? Well, this is where in Eagle you'd be hunting around for some other kind of Gerber viewer. In KiCad, there's one built in. I've preloaded them for speed, but you can it's just File, Open Gerber plot file, select all of these, click open. Job done. This looks a bit strange because all of the layers are turned on and you can turn them on and off and check that these are plausible. This is all of the drills, little tiny vias here and other component holes. What else should we turn on? Let's turn on the bottom copper just to check that we got the ground plane fill, and we did. The resolution of the screen makes it look horrible, but actually it's, you know, it's a vector format file, so don't worry about that. These are strange because I put traces into pads which are on the ground ball. You don't need to do that, but it makes them look a bit weird. Check.
Oh. Lost him.
I'll just give Peter a minute or two to see whether we can put another shilling in the meter.
Let's come back now.
Peter, we lost you there for about 30 seconds.
Are we back?
Did you put some more money in the meter?
Yeah, we're back now.
Yeah. Sent the dog down with a biscuit.
Excellent.
I don't know where you lost me, but I was just prattling. It's not important. I've gone back to the PCB view now. I checked my Gerbers. They all seem plausible. I just want to have a quick look and make sure that the whole thing is what I'm hoping for, and built in is the 3D viewer, which tells you pretty much exactly what you're going to get. And that's it, really, in terms of the demo. Questions about KiCad?
Okay, yeah, the 3D thing looks okay, or looks
Yep.
good. Can you export that so that you can use it in a CAD program?
I think you can. I think you can export it as a step file. Export as PNG, edit. I have a feeling somewhere I have seen you can make a step file from it, but I don't know for sure.
Okay, I'd be surprised if you can't. It just might be fiddly.
Yeah. It would be nice if you can, though, because it would certainly make life a lot easier, but I don't honestly know. It would be worth looking up. Having gone to all the trouble of generating it, it would seem stupid not to actually let you do that, but that's not an option there. I'll check it out. Yeah, okay.
Quick question: how did you get the bends in the wires of the LEDs?
Oh, I didn't. I glossed over that neatly, I thought, up until now. These models are not drawn by me. These models, these are already provided, right? So for the vast majority of basic components, you'll find that there are 3D models, but not for everything. So, you know, all of your common packages will be there. And for example, for this particular size and style of LED, you can have any color as long as it's green. I don't know why. For this one, you can have in black, right? Actually, to be fair, you can have that one in black as well, but you can't just arbitrarily pick the colors. It's constrained. It's a representation. And if you have some unusual part or some part you've made yourself, it's unlikely to have a 3D model. It's eye candy, but it's kind of handy eye candy, because, for example, on this view, I can see that placing the part numbers, the part IDs here, isn't very clear, and for some reason your perception is different. So it's perfectly plain, having seen this, that this D3 would be better up here, and then there would almost certainly be, and C1 could come over here somewhere, and then all of these resistor names could sit here. There seems to be plenty of room, and they'd be much easier to read. Right? So it has its uses.
Okay, but the question was, have you got different sort of selections for LEDs with bent leads as opposed to LEDs sticking straight up?
Yes, you do.
Yeah.
Different footprints.
Okay.
Yeah,
that's right.
That's back in the footprint thing back here. So if I pick that LED and I want to change the footprint,
Right. Okay.
So we're in a different view of the editor now, but they come in, it's a bit hard to see when they auto scale, so they come in different offsets from the LED body to the holes,
right,
and in different offsets off the board.
All right.
Yeah, so there's enough to get you going. If you don't really necessarily want a full realistic rendering of your thing, it just gives you an indication.
Yeah, that's fine.
Right. If you want to find out more, and I haven't.
Sorry, just one quick question, Peter.
Yeah.
Is it possible to say import a schematic from Eagle and edit it?
You can import an entire project from Eagle. Yes.
Oh, okay, great. Thanks.
But does it work?
Check it.
Yeah.
I imported UKMARS bot into KiCad, and as far as I can tell, it's all correct. I haven't checked it carefully, but obviously it would be sensible to do that. But there is specifically an Eagle importer.
Oh, I might mention one other thing. Like Eagle now, everything is in a text file. So if you're an aficionado of Git and keeping track, here's the Git view of the project, and these are all of the Gerber files that I just generated, and I can add those to my Git repo. Type Gerbers. Commit that. Oh, forget that. I've done it on the wrong. I haven't set up Git properly on this machine. I did all of the practicing downstairs on a different machine. But you can commit all of those changes, and you can see the various steps. And you can always go back, right, and try a different design choice, or you can branch off. And so if you had two different versions of the board, you could do a little branch here, and you can have two different versions and maintain them all in Git. That's good too. So if you want to find out more, there are a number of resources. Follow the links. John's basement has got a lot of KiCad tutorials. He's a professor at someplace. Entertainingly, it's not on, is he? He sounds a bit like Dave Otten. It's not Dave in disguise, but it's something about his voice and mannerism that makes him sound a bit like Dave Otten. But he's got good stuff, and he'll lead you right through every step. And after about 6 videos, you've got enough to do anything probably that you want to do, and there's plenty more. Contextual Electronics is the other most cited source of tutorial information. Chris Gamble, he's very good, all sorts of stuff, fairly brief. Phil, I've forgotten his surname, Phil's Lab. He's a design engineer. He's got one of the projects in the Made with KiCad examples list, and he has some very clever stuff. His example is a flight controller for quadcopters, and he's also done some recent good videos on control systems and Kalman filters if you really are that desperate. Plumpot KiCad tutorials I've come across recently, a bit more lightweight, but good stuff. And then there's the documentation itself. And the Made with KiCad examples, they just lead you off to projects. There is an entire laptop design done in KiCad, lest you think that it is in any way not up to the task. All right? If you can't design what you want to design with KiCad, it's your fault, not KiCad's. A whole laptop, I mean, honestly. If you want to send stuff off to manufacturers, done by Osh Park, you know, perhaps you may or may not know Osh Park charge you by the square inch. 3 of these done cost $16.50 and arrived in about 3 weeks. If you order them from JLC PCB or PCBWay, they have instructions on how to generate the Gerbers to their specification, and they have specific design rules pages for your reference. Either of those will deliver. You can have 4 of these per panel, 5 panels delivered to you for about $25. So you could get 20 of these for about $1 each or £1 each or something. If this one works, we might send them out. But Ian's done a 4-sensor board as well, haven't you? That's it. At long last. That took a while, sorry.